Hello, my name is Putty Fafana and I am here to run through my final assignment for the Machine Learning Foundations for product managers, and this is my final assignment. So let's get started. So the problem that we were required to solve was we needed to build a model which would help predict energy output of a combined cycle power plant. This combined cycle power plant uses a range of different things, so like turbines and different generators to generate power. There were 9,568 hourly average ambient environmental readings taken from sensors at the power plant, which would be used in the model. And the different data sets features would be kind of temperature, ambient pressure, relative humidity, and exhaust vacuum, and all of these would be used to help predict the electrical energy output, which is what we're trying to use them all for. So the specific tasks that were required to be completed as part of the project, we needed to determine what type of machine learning approach is needed, and select an appropriate output metric. Then to determine which possible features we may want to use in the model. Splitting our data to create a test set to evaluate the performance of our model, and use a training set to determine a validation strategy for comparing different models. And then once we'd done that, then we were able to validate our approach and compare the models, and then finally evaluate the performance of our final model. So first off, the approach. So the approach we took was the multiple linear regression approach. This was used as there are multiple independent variables that are determining the outcome of a single independent variable. So we've got temperature, exhaust vacuum, ambient pressure, and relative humidity. Each of these features are numerical in value. They all indicate a linear relationship, and we didn't have any hyperparameter tuning requirements. So this is why we felt like multiple linear regression was the best approach. Following on then, so we need to decide which features we wanted to use in the model. So in the first model, we decided that we would keep all the features and test all the features initially. So that included temperature, exhaust vacuum, ambient pressure, and relative humidity to help predict the energy. But what we then did is we looked at the different features and their correlations between that and predicting the energy output to really find out which of these features had the least correlation with the energy output, so that we could remove that in a second model to help to see if that made a difference to our predictions. So what we were really trying to determine is, are all these features necessary? In kind of carrying out this exercise to look at the correlation, what we found was relative humidity did actually have the least correlation to the energy output. So that was the one that we removed for model 2, so that we'd be able to compare to see how much difference it made. So to do all of that, what we did do is we split the data. We had a training and test set, and we used fixed split validation, and we settled on 80% training versus 20% test. So of the 9,569 we had around 7,655 for training, and 1,914 for the test. So in model 1, we had a 4-feature model, so that included temperature, ambient pressure, exhaust vacuum, relative humidity. I mentioned the test sample size previously, and this produced an R-square value of 0.92962. And then in the second model, where we only had a 3-feature model, so we omitted relative humidity, as it had the least correlation with energy output. On the same test sample size, it was an R-square value of 0.918526. So from there, then we were required to evaluate the 2 models to decide which model was most appropriate and best at predicting the energy output. So what we did was we calculated the mean absolute percentage error, or MAPE, which essentially converts error to a percentage. And what we found here, you can see that we've got a slightly higher MAPE percentage here for model 2, which would indicate that model 2 is slightly less accurate. Model 2 being the model that only used the 3-feature set. So that would indicate that the model 1, where we use all 4 to predict the energy output, was the best route to predicting the power. So this the MAP was really good because it meant that the results were fairly easy to interpret and determine which model was the best. Thank you, that's all.